right? So in last class we discussed objectives of replacement theory. That is not what why we need the replacement. Then after that we studied some basic definition and the outline of the replacement. That is nothing but whenever running cost increases, scrap value or resale value decreases, at that point, whenever the total cost is minimum for that particular year, we have to replace our machine or replace our equipments, right? So in this class, we are going to study one model, a replacement of items whose maintenance cost, whose maintenance and repair costs increases with time. So in this model, we are learning one model that's nothing but replacement of an equipment or replacement of items whose maintenance cost as well as repair cost increases with the time, right? So here we are ignoring changes, ignoring the changes in the value, of money during the period, during the right? So in this model we have to ignore the value of the money in that particular period. Suppose you are consider that vehicle example. In initial years we have certain cost, right? So after that there is increase in cost of that the same vehicle for the same brand, means we are not considering that new one uh, amount or new one cost at the time of beginning of our old one. What we have that cost, we have to considering that cost only. That is not what, suppose there is any changes made in money or suppose there is any changes in that costs, we are ignoring. So the first model, that is nothing but replacement of an items whose maintenance and repair costs are increases with the time. For this, let us consider a simple situation which consists of minimizing the average annual cost, right? So in this model, in this model, our main aim is to minimize minimizing the average annual cost. Average annual cost, or average annual cost is nothing but our total cost, right? So in this model, we have to minimize the average annual cost or total cost, right? We have to construct one function, right? You know that function is nothing but a mapping, right? So we have to consider one function. That function includes total annual cost or average annual cost, right? So what our aim is to replacement of an items whose maintenance and repair cost increases with the time, right? So suppose you consider time as a continuous variable, means we have certain models. Suppose you consider time as a discrete variable, means we have certain models, right? So first I consider the first case, that is nothing but, suppose we consider time as a continuous variable, right? So that's nothing but case one. Case one, when time t is when time t is continuous variable, when time t is continuous variable, right? Suppose, I mean, our study is to replacement of an equipment, so we have to find out the time, right? I mean, in which year we have to replace our old equipments, right? So that depending upon the time period. Suppose you consider time as a continuous variables, we have certain derivation, I mean certain model. Suppose you consider time t as a discrete, means we have certain different models. Okay, first we learn about the time t is continuous variable. For this, let us consider some notations. C, capital C is equal to, I mean, capital C means capital capital cost of equipment or capital cost of an item. Capital cost is nothing but purchase cost or capital cost, same. That is denoted by, in the replacement theory, by English alphabet C. Then next, S is nothing but scrap value of an item. Scrap value of item, or it is also nothing but a resale value. A resale value of an item. Okay, then the next, I mean, just we are going through the terminologies. So the next terminology is T average. That's nothing but total average. Just a wait. Okay. So T for total here, average. Total average is equal to nothing but average. This terminology or this notation means average annual cost or total average annual cost. Annual cost or total average annual cost of an item, of an item. So the next terminology is N. Small letter N means number of the years. Number of years the item is to be in use. I mean, how many years that particular item is used. That's not what number of years of the item is to be used. So this is, I mean, these are some terminologies. We have some more terminologies. Next, we are considering f of t. So the next terminology is f of t. Is it screen visible rightly or not? Is it audio and video are at a time or not? Or there is disturbance between audio and video? I hope it is clear, right? So next, f of t. F of t is nothing but operating and maintenance cost of the item, right? So next, annual cost of the item, annual cost of the item at any time t is equal to capital cost minus scrap value plus maintenance cost plus maintenance cost at time t, right? So this is the one of the important equation in our derivation, that is annual cost of the item is given by capital value or capital cost minus scrap value plus maintenance cost at the time t. So now total maintenance cost, total maintenance cost during n years, right? So what we defined that total cost T average for the 1 year, right? Suppose we want the total maintenance cost, right? So here total maintenance cost for the n year, I mean entire n years is given by integration over 0 to n f of t dt, right? So we know that f of t is nothing but operating and maintenance cost of the item at the time t. Suppose we want total maintenance cost means integration. Suppose why, because we are using why integration means our t is, this time t is continuous case. Suppose the time discrete case means we are using, instead of integration we are using summation, like that. So we want entire total maintenance cost during n years, so that is integration from 0 to n f of t into dt, right? Therefore total maintenance cost, therefore total maintenance cost equal to C minus S plus integration 0 to n f of t dt, right? So according to that formula, capital cost minus scrap value plus maintenance cost, that is capital cost C minus scrap value S plus maintenance cost. We want maintenance cost for the n years, so that is 0 to n, integration 0 to n f of t dt. Therefore next, average annual cost, average annual cost equal to, I mean that notation is average annual, sorry, average ATC, right? Average total cost, that is for entire n years, so that's why it is n. So it is given by, we want average, it is total. We know that average is nothing but sum of the observation divided by number of the observation. So it is total, that's nothing but sum of the observation and divided by its number of observation, that's nothing but 1 by n into C minus S plus integration 0 to n f of t dt, right? So this is nothing but average annual cost, that is 1 by n into C minus S plus integration from 0 to n f of t dt, right? So next, it is described to find the value of n for which annual, sorry, which that average annual cost minimum, right? I mean we want a minimum of this function, right? Suppose you treat this annual, sorry, average annual cost as a one function, we want minimum value of this function for any function suppose we want minimum value, means first we have to differentiate, right, with respect to what we required, right? Suppose we required for the years means n, suppose we requires for the time means t. So we have to differentiate this function. It's nothing but d by dn, because I want minimum number of years, right? I mean, why I want minimum number of years means after that years I have to replace my machine or replace my equipment. So that's why I want some years. So that's why I have to uh, differentiate with respect to n. So we have to differentiate which function? This one, that is annual cost function. It's nothing but annual cost function is equal to after differentiate, it is minus 1 by n square c minus s minus 1 by n square integration 0 to n f of t dt plus 1 by n fn, right? So I am applying here differentiation under integral sign rule. I hope you have aware of that rule, right? So after applying, this is nothing but first derivative of this function. So next we have to equate into 0, that differentiation of that average annual cost. For this we have to equate into 0. That's nothing but minus 1 by n square c minus s minus 1 by n square integration 0 to n f of t dt plus 1 by n fn equal to 0. So then 1 by n fn I will kept same. Then I will take these two functions from LHS to RHS, that is equal to 1 divided by n square c minus s plus 1 divided by n square integration from 0 to n f of t dt. So here 1 by n fn, 1 by n square common. So I will take 1 by n square as common. Then I left c minus s plus integration 0 to n f of t dt, right? So next f of n equal to n divided by n square, right? Because I will take this n this side, so it becomes n divided by n square. C minus s plus integration 0 to n f of t dt. So n square get cancelled. F of n equal to 1 divided by n c minus s plus integration from 0 to n f of t dt, right? So our function that f of n is nothing but average annual cost, right? I mean, what we written, both are same. I mean, we wrote exactly same. Thus the item should be replaced when average annual cost is to be to the date equal to current maintenance cost. That's nothing but, this is nothing but a function of n. That's not but a function of year is nothing but we have to replace our item in this n year, right? So when that n, I mean when that item should be replaced, means whenever your annual cost or total or average annual cost equal to this function, I mean equal to in this function is in that particular year we have to replace our equipment, right? That is nothing but whenever average annual cost to the date becomes equal to current maintenance cost, right? So this is not maintenance cost, which is equal to current maintenance cost. So using this result, we can decide when to replace our item, right? I mean, using this result, we know that when to replace our old equipment, right? So this is nothing but a derivation whenever you consider t as a continuous variable. Is there any doubt with this one? Is there any doubt with this derivation? Okay, is there any doubt with this derivation? Yes or no? Okay, so I'm going to end this session now. We'll meet afternoon 1 o'clock. Thank you. Have a good day.